A wave is a disturbance or an oscillation that travels through space and matter, accompanied by a transfer of energy. There are two types of waves, longitudinal waves such as sound, and transverse waves such as waves in the electromagnetic spectrum. Waves in the EM spectrum can transfer energy without the use of a medium, meaning that it can travel through a vacuum, allowing them to reach Earth from the Sun. The spectrum is divided into 7 sections, the only difference being wavelength and frequency. As shown as here, wavelength lambda is equal to c the speed of light over frequency. The higher the frequency, the more energy is transferred. Radio waves have the longest wavelength, up to 100 kilometers long. With the lowest frequency, these are used for telecommunications such as AM and FM radios, as well as MRI in the medical field. Microwaves are used in cooking appliances, telephones, and radar imaging. Overexposure to the microwave radiation can cause denaturing of protein cells, such as in the lens of your eye, which severely damages vision. Infrared waves are slightly longer than the red waves in visible light, so traces of red light in IR give it a red color. Infrared waves are used to track heat by using thermal imaging, since everything above absolute zero radiates infrared. Thermography allows us to see objects without visible light illuminating the area, picking up this infrared radiation. This can be used for alarms as well, by sensing a movement in the thermography of the environment. Visible light ranges from red to violet, and this section of the EM spectrum is the only one that humans can see with their naked eye. But what are we actually seeing? When white light shines onto a surface, certain colors are absorbed, and what isn't absorbed is reflected, which is what we actually see, such as the green light from the tree here. White light can be split into its different wavelengths by shining it into a prism. A water droplet is commonly used, for example. When these droplets are located at 42 degrees from the opposite direction of the sun, these wavelengths are split up and form a rainbow. Ultraviolet waves, much like infrared, these wavelengths are just slightly shorter than visible light, so violet light can be found in UV, giving it the purple color. UV light can be very useful as it can allow us to see things that we normally can't see, such as the authentication signs on a dollar bill, or blood spill at a crime scene. Overexposure to UV light from the sun without protection can result in sunburn and skin cancer. X-ray waves can be used in medical practice, often in X-ray scans. The very short wavelength of these allow them to pass through our flesh and blood, only being stopped by our dense bones. Gamma waves have the shortest wavelength and the highest frequency, therefore they transfer the most amount of energy. These can be harmful to the point of death, and yet can be used to kill cancer cells in chemotherapy.